Alright guys, today we're going to talk about the last form of quadratic equations, which will be intercept form. And the reason it's called intercept form is because, just like our other forms, you can pull something out of it, and specifically you can pull out your x-intercepts. So you can pull out from intercept form, you pull out your x-intercepts, okay, which are in the form of p, comma, 0 and q comma 0. So those are the numbers inside of the parentheses here. Alright, just about and just like in our vertex form, the most important thing to remember is that the signs are going to be opposite. Okay, so your signs are going to be opposite. So like on our first example, your intercepts are going to be 3 and 0 and -1 and 0. Okay, so just remember that. Also, from this form, you've got to use your calculator to get your vertex and your y-intercepts. Okay, but that's easy. Remember, your vertex you get from by going to second trace, min or max depending on your graph, and then doing your left-right bounds, and then your guess in the middle. Your y-intercepts, again, you use your second trace menu as well, but you go to number 1 and enter a value of 0 and hit enter, and that will give you your y-intercept. Okay, very easy. Everything else is going to be exactly the same as we've been doing. Your focus, you're still going to find the same way. Your axis of symmetry is going to come from your x value of your vertex. Your min or max value is going to be the same as your y value of your vertex. So all of that is going to be exactly the same. So I'm not going to go over specifically all of that again. We're just going to do some examples. So starting with our first one. So our p in this first problem is going to be 2, and our q is going to be 5. Okay, we're just going to remember that these are the opposite signs. So they're both being subtracted here, x minus 2 and x minus 5. So that's going to create x-intercepts of 2 and 5. Okay, 2, 0, 5, 0. So we're going to graph those. Okay, 2 and 5. Okay, now I'm going to plug in my function into my y equals. Make sure you put a 0 in for your y2, and I'm going to find that my y-intercept by going to second trace and number 1 for value and putting in a 0 for my x value will give me a y-intercept of 0, 10. Okay, so I'm going to graph that up at the top. Okay, so next I'm going to find my vertex, which on this problem, because my A here is just a 1 and it's positive, it is going to be opening up. So my vertex, I'm going to look for a minimum. So when I do that in my calculator, I'm going to find that my minimum is 3.5 and a negative 2.25. Okay, alright, so, and I graph that as well. Now, that means that my graph should look something similar to this, and so should yours. Your axis of symmetry, of course, is your x value of your vertex, so that's x equals 3.5, and my graph opens up, obviously. Okay, and I have, so that therefore I have a minimum value that is the same, and there's my axis of symmetry, and then I have a minimum value of negative 2.25, okay, which is my y value of my vertex. And we're done with that problem. So moving on to example number 2. Okay, my p and my q in this problem are 4 and 2. So my x-intercepts, because the signs are opposite, are going to be negative 4 and 0 and 2, 0. Okay, and I'm going to graph those as I've done here. Okay, then I'm going to put this in my calculator. I'm going to find my y-intercept by using my second trace menu, second trace and value, and I'm going to find that my y-intercept is 0, 4, and I'm going to graph that as well. Okay, then I'm going to move on to my vertex, which I find by finding my min or my max. On this one, it's going to be a max because my a is negative it's a negative 1/2. Okay, so I'm going to be looking for my maximum, and I get my vertex at -1 and 4.5. So, and then I'm going to graph that as well. Okay. Next, my axis of symmetry again is my x value of my vertex, and it's a vertical line up through the middle of my graph. So my graph should look somewhat like this. Okay. And so it's x equals -1 is my axis of symmetry, and I'm going to graph it right down -1 x line. Now my focus and my directrix. I'm going to write this up top just to give myself a little bit more room to work out the problem. Okay, so again, I'm using my equation P equals 1 over 4a. Okay, so and my a in this problem again is -1/2. So P equals 1 over 4 times a -1/2. Okay, and that will, I can put it in my calculator just like that, 1 over open parentheses 4 times -1/2, and it will give me a -0.5. Okay, a -0.5. This is the distance that I count from my vertex to my focus, and my focus will always be on the inside of my equation, or the inside of my graph. So my focus will be right here, about 0.5 in, which will put my point at -1, 4. Okay, remember your focus is always on that axis of symmetry, so it's always going to have the same x value as your axis of symmetry and your vertex. Okay, now to find my directrix, I count from my vertex the opposite direction above my graph. Okay, 0.5, and that should take me to y is equal to 5, and I'm going to draw this line right there. Okay, all right. Moving on, last example. So my P and my Q here are 1 and 5, okay? And so my x-intercepts are -1 and +5 because they're opposite signs. Okay? Looking at my A, it's going to open down because my A value is negative, okay? I put this in my calculator, and I find that my y-intercept is 0, 5. Okay. Next, I'm going to use my calculator and find that my vertex is at 2 and 9. Okay, 2 and 9. So my graph should look like this. Make sure yours looks the same. The axis of symmetry, again, is going to be the x value of my vertex, and I'm going to graph that as a dashed line straight up and straight down. It's a vertical line. Okay, I'm going to have a max value of 9. Okay, and this problem, okay, when I'm looking for width or narrow, again, I'm looking at my A. Remember, if it is bigger than 1, then it is narrower, and if it is wider, then, if it is wider, then it is going to be less than 1. So, this problem actually, although my A is -1, okay, so it's actually neither. It's neither wider nor narrower. It's just flipped. It's the same width as my parent function. Okay, those are our notes for today, guys. Remember, the biggest thing from intercept form is it gives you your x-intercepts, and the signs are going to be opposite when you pull it out. Everything else will be the same as what we've been doing before. Okay, get started on your practice, and which will be due next time.